Welcome to the third video on essential concepts for printing and prepress. In this video, we'll talk about halftone screens and dot gain. All the other concepts listed here were discussed in other videos. So one of the main concepts that comes with printing is the halftone screen and halftone dots. A press cannot print a graduated shades of gray, these continuous tones of gray, without the use of halftone screens. That's how it's done. If you look at this eyeball picture on the left, there is a photographic quality to it where it has these shades of gray. Sorry, there's a little bit of digital artifacts going on there. There's shades of gray that in a photo developed with film, you get those through the chemical process. But when it comes to trying to reproduce that on a printing press with ink in printing plates, you can't get that smooth tonal transition. Instead, they use what's called halftone dots. And the halftone dots are like on the eye on this right here, these little tiny dots that are arranged in a grid. And that grid of dots is called a screen. So the halftone screen and the halftone dots is how we are able to reproduce gradients, photographs, color, tonal changes, and so on. So you can see in this diagram below, that looks like a gray square, but as you zoom in, it is a series of dots arranged in a grid. Oops, sorry about that. So it's pretty critical for offset lithographic printing and most other forms of four-color printing, with the exception of letterpress printing. Screen printing does use screens. Their halftone dots are not as fine and as detailed as offset printing, but letterpress printing, it can use halftone dots as well, but the same thing. It's not as fine as lithographic offset printing. So the way that works is that each color of the CMYK will have its own plate, and each plate will have its own screen pattern arranged on it according to what is being printed. And the screens have to be, since they're on a grid, they need to be laid out at angles to each other. So here you can see that we have black at a 45-degree angle, magenta at 75, yellow at a 90-degree angle, cyan at 105. There's variations on this. Another one is where yellow is at 0 and magenta is at 15 and cyan is at 45 and black is at 90 or something. So there's variations, but there is mathematical formulation to it in order to get the dots to appear in a pattern such as this. They call those rosette patterns. Whoops. So that there's no discernible pattern coming from the CMYK screens, and our eye blends it all together and creates this wonderful photograph of this little boy with blonde hair smiling in the sun. One concept out of this is dot gain. I'm going to get back to screens here in a minute, but dot gain is the tendency for dots to expand once the ink is laid down on paper. So if you think about putting a pen, an ink pen, on a piece of paper, you dab it and you can see the ink spread out sometimes. Well, it's like that. It doesn't spread out that much, but essentially the paper grains absorb up some of the ink and the dots can get a little bit bigger. And the result of that is that colors will look darker when they're on the paper. Uncoated papers have bigger dot gain because they absorb ink and allow the ink to spread more. So like a newspaper generally has a 20% dot gain, which is significant. So if you had a 50% screen here on the left and you print it on newsprint, those dots are going to expand to 20% dot gain. So when it comes to preparing black and white photos for a newspaper printing job, you generally want to have them appear lighter on your screen, on your computer monitor, and so that when they get printed, they will darken up through the dot gain and they'll look just right. And so the printer, if they know you're printing on newsprint, will ask you about dot gain. They may ask you about it, but it's something to consider when you're printing on newsprint. Just some more about screens. As I said, a printing press needs halftone screens, halftone dots and screens to make these photographic reproductions. Sometimes the dots aren't always round. They can be diamond shaped or elliptical or square or linear, but they're generally arranged on a grid. But there's an exception to that too. And so when you have a screen, a line screen, they call it, they take the measurement of it and they call it lines per inch. What's the line screen of this plate or this press or this type of printing? So as I said earlier, screen printing can use halftone dots, but because of the screens themselves, they're limited physically to like 45 to 60 lines per inch on the screen. And when I say lines per inch, I'm talking these lines here. So this row would be 1 line, 2, 3, 4, 5, 6, 7, 8, 9, 10. We see like 10 lines there. That's like a row of dots would be the lines per inch. So screen printing 45 to 60 lines per inch, that's pretty rough, and you can see that without a microscope or without a magnifying glass. If you look at t-shirts that have been screen printed and they've got a gradient on it or something, if you look at it a little closer, you can see the dots. Newsprint runs about 85 lines per inch, and even that you can see with your regular eye. If you look closely at it, you can see the halftone dots in there. When it comes to high quality printing, commercial presses, we're looking at a minimum of 133. 150 lines per inch is pretty common, and it's getting up to 200 and 300 lines per inch now with higher quality, newer presses. And so we get finer detail. The smaller the halftone dots, the more dots you get in per inch, the more detail you can get in higher quality photographs and sharper edges and printing. So one thing also to note here is that there's 2 types of screens. The halftone dot screen is called traditional, and that's what we have had for a long time. But more recently, there's this FM screening, or called stochastic screening, and that's where the dots are just grouped closer together, but all the dots are the same size. So here you can see on the left, the dots are all the same size. They're just arranged and grouped closer together or farther apart to mimic the darkness of the color. Where here on the right, you have the traditional screen where the dots are on a grid. They stay in the same place and the dot size changes to mimic the density of the color. If you were to look at like a single dot, like take one of these dots over here, and if you zoom in on it, this is how a laser image setter creates dots, is that they break it down into even another smaller grid, and they use that grid to create the dot. So this is like a 17% gray dot right here, but on the left side, this here would be stochastic screening. They would space out the smaller dots to create that 17% type of gray. So I hope that kind of makes sense. And this smaller grid here is what they really call dots per inch with a printer. So if you say, oh, this printer is 2,400 or 4,800 dots per inch, they're not talking line screen. They're not talking these dots per inch. They're talking the tiny little dots that make up the dots. So they are the smaller dots to create the actual halftone dot. And that way, the higher resolution you get with that, then the finer shape halftone dot you get, and the better quality, and so on. Here is just an example of full color with stochastic screening at the top, the FM screening with the dots placed closer together or farther apart compared to halftone dots on the grid. So as I said, the dots are laid at an angle because our brains automatically pick out patterns and things. So if we were to look over here at this, if you have the dots just in a 0 degree or 90-degree pattern, I'm going to zoom back out a little bit maybe, you might start to see other patterns forming where if it's laid at a 45-degree angle, our brains don't see the patterns as well, or they don't make up patterns. So we got the screen angles there. This is the other example here, 0, 15, 45, 75. I'm not expecting you to memorize screen angles, but when they are laid out at the right angle, then the dots will form patterns that are good patterns called rosettes. And here's 2 types of rosettes. And the rosette is a good distribution of dots that we won't see it as a pattern unless we zoom in on it. So looking for rosettes is good. Finding other patterns is bad, and part of that is called moire screens. So here's where screen angles are misaligned, and we get what is called a moire. Oops, sorry about that. Whoops, zoom in on this here. So you may have seen that in other places. Here's where a pattern on the actual image itself conflicts with the dot pattern and creates other patterns that our eyes pick up, and those are called moire patterns. Sometimes that's unavoidable, and the press operator or the pre-press would have to go back and remake plates and use a different screen angle settings to try to not get moire patterns showing up there. There's an activity we have on finding moire patterns in the class. And lastly, this is the screen I was talking about. So, lines per inch versus dots per inch. So, and pixels per inch. So here we have a view of dots, and the way that the dots are made is through image setters. And the image setter will have a grid, and it'll pick out and it'll fill in the squares on that grid to create the halftone dot. This is actually the best one right here to look at. So if you think of pixels per inch on your computer screen are squares, and they're all connected beautifully like that in a grid. And if you convert that to the lines per inch, this is your line screen for your halftone dots. So here we have, like, say 3 LPI, if that was an inch wide. But then to create these halftone dots, you have a smaller grid that will fill in to create those dots. And so if there's, say, what is that, 5, 10, 20, 30, this would be 30 DPI across. This is 3 lines per inch, and this is 6 pixels per inch. So the general formula is that you want twice as many pixels as you have lines per inch. That's why 300 pixels per inch is the standard for a digital image resolution. And 150 lines per inch is the line screen for the press. So 150 times 2 is 300. So you want your images to be at least 300 pixels per inch, and line screens will be about 150 or more. But then the DPI is the dots per inch that creates the lines per inch. Anyways, that is drilling down into halftone dots there. And let me know if you have any questions. Thanks.